Scott Cunningham here, owner and founder of ArcLight Dynamics, here with the second installment in the training series on how to operate your ArcPro X and ArcMax series plasma tables. So this series we're going to be loading up a code and talking about how to do what's called a dry run. So first thing I'm going to do is power up my system here. If you already have your system powered up, you don't have to worry about it. Pull it out of e-stop. I already have my motor power on. And I'm going to set my machine home. Now, if you've already set your machine home, your machine's been powered up, you don't need to do this. But this is just replication to ensure that, yes, in fact, we have set our machine 0. So I've set my X and Y. I'm going to 0 those. Jog a little bit over on this plate. Now, again, let me pull up the camera so you can see what I'm looking at. Again, if you don't have a plate, you can simply jog very close to the material, or where you think the material would be, and 0 it out there. That's fine. Okay? Or I can go home Z. So, our machine 0 has been set, as you can see. Okay? So, if I come over here and let me get rid of my lines by hitting clear toolpath, my machine 0 is here, and as you can see, my position of my torch is up here. Okay? So first, let's load up a code here. So what you can do, you're going to go over to Open, and I want you to navigate to the desktop. Okay? So there's a side note here. It's important to understand how Linux does its file structure and whatnot. It's very similar to Windows, but not exact. Okay, you can see we are in the Plasma, and then in Linux CNC, and then in NC files. That's kind of the order of the file structure we're in currently. All right, if I go to Desktop, we are in Plasma Desktop. Now, Plasma is the machine's computer. It's called Plasma. All machines will be called the same. Okay, so it's helpful to understand where you put your files, and they can be in the file system. What we recommend is setting up your own files. For instance, on this one, they've set up a Plasma file. Okay, but for the most part, I recommend keeping things on the desktop. So on your desktop, you're going to find test files. Okay, if you open up this, you are going to find this wire mount. Now, .ngc, that's very important. That is a G code. Okay. Commonly, other files will be called DXFs. Those are CAD files. Okay. So you just want to remember that you're always trying to, when you're loading a code up, a part, you're trying to look for an NGC file. And the NGC files are created in SheetCam. If you haven't already gone through the SheetCam training videos, I do recommend it, as it will be very helpful. But you don't necessarily have to at this point, but you will when you're done. So you can't skip them. So we're going to click on the wire mount. Double click on it and open it up. So now it pulls it up. Turn off the camera for a second. So the first thing you want to notice, it displays your part here in the part display, and it gives you measurements. Now, these measurements can be turned on and off by toggling the measurements on and off. Okay, but they can be handy. You can be sure that I need to know I have a piece of plate at least this big, if slightly bigger, in order to cut my part out. Okay, so this here is your G code. Okay, this X here represents the current position of your Z-axis. Now this is currently off the machine. It's saying it's on the machine home. Okay. Now we'll have to zero this out again to set the part home. Okay. Because I cannot, if I pull up the camera again, as you see, get all the way down to the machine 0. I'll be off my plate. So that's not correct. So if I'm going to start my cut, say here, right on the corner of this plate for this part. So one thing, when you're starting your cuts, you always want to inset a little bit from the edge. So I don't want to start right on the edge. Inset a little bit from the edge in this way, inset a little bit from the edge that way. Okay. Now depending on how comfortable you are will depend on how much room you give yourself, but I recommend initially 1/4 inch. So give yourself some extra room, because you do not want to run off the edge of the plate and lose arc. It's a very easy way to lose your part. Okay, so with the position where I want to make the cut, I'm going to set the part 0 by going 0x, 0y, 0z. So as you can see, it has moved the part up and to the right. My machine 0 is still set down here, and now I have a part 0 where I need it. So if I jog around, the X will follow where I am, and I can tell, do I have enough room on this plate to cut this part out? Well, yes, I have enough room vertically that way, and I have enough room if I go this way. I have plenty of room to cut that part out right here. So, and again, if I want to get rid of this yellow line, I can simply click that button. So my part 0 is set, so the machine knows to start the cut down at this lower left. Okay? So I don't have to actually jog back to the 0 point once I've set my machine 0. If I hit run, the machine will go to the first cut. So now I'm not exactly sure. I believe from the looks of this, my first cut is up here. I see a dotted line going from the start point. So yeah, I believe we're going, oh no, I think we're going to start here. Cut here, 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 back to the start point, and then do this cut. So generally the machine, if you keep your standard settings in SheetCam, you will cut the interior cuts first, and then the exterior cut of a part, and then it will move on to the next part. I'm just going to clear this line to kind of make this a little easier to see. So, your G-code window, this displays the G-code. Okay, so this is a list of instructions that your machine reads in order to move the table properly. So this first section is all very important information. It must be read. So it's very important that when you first power up your machine, the machine reads through this top section, because it sets some key features in the machine. I'm not going to go into those, but very important that it reads that. Okay, so for starters, what I'm going to talk about is doing a dry run. Okay, so currently I have my machine set up. I have my plate on, and whenever you do a cut, you want to do a checklist to make sure everything's, because there's a bunch of different things you have to make sure are properly set in order for you to get a good cut. Number one, you want to say, okay, table's turned on, it's powered up properly. There's nothing in the way of the motion of the gantry. There's nothing on my side rails that is going to cause a problem in this motion. I have my plasma cutter plugged in. I have air to my plasma. I have it set to the right amperage. Okay, it's very important. You must set your amperage on your plasma manually by actually turning the knob. The computer's not going to do it for you. And you have to make sure you have the right tips in the plasma, okay? Because your plasma can have lots of different cutting tips. You can have, if you say for instance you have a PowerMax 85 amp plasma cutter, well, you can have an 85 amp standard tip, a 65 amp standard tip. You can have a fine cut tip. All these tips require different settings and different amperages to operate properly. If you try to cut a part with, say, 65 amps with an 85 amp tip, you will not get good cut quality. Okay? If you try to do vice versa and cut 85 amps with a 65 amp tip, you will blow the tip out because it's too much power for that tip. So each tip is specifically designed to give you the best cut quality on that particular part. Okay? So, so make sure that your plasma is set up properly. Number one, very important. Okay? Once you know your plasma is set up properly, you want to make sure, is my operation set up properly? Okay? So I can drag this little display over, and I can kind of shrink up the display. It lets me read my code better. So if I read down through the code, I'll have the name of the part, okay, that it's in inches, okay. I will have the operation, it's an outside offset, and what tool I'm using. This is very important. So I'm using a fine cut 45 amp 16 gauge tool. Therefore, I have my plasma cutter set to 45 amps, and I have fine cut tips in, and this is 16 gauge steel that I'm cutting. Okay, you want to make sure that know that your operation is set up properly. Okay, so first off, I want to talk about doing what's called a dry run. Okay, a dry run is basically letting the machine move through the motion of the cut without it cutting. Okay, this can be very helpful when you're first starting out with your table, so that you can get a feel for what is the machine going to do. Is it going to run through the pattern properly? Is it going to, have I zeroed out in the right spot? Is it going to try to move to the right spot, for example? So in order to do a dry run, you have to have your code loaded up. Then you have to go down here and go click on this option, disable torch. Okay, so that's going to prevent your torch from firing when it operates, runs through the code. Okay, so let me move this off to the side a little bit. I'll just shrink it. So when I hit the run button, the machine is going to read through the first part of this code, and it's going to set all these key settings. Okay, one of the most important ones is your torch height control voltage. Okay, as you can see, my preset volts is right here, 120. Now we're going to discuss the torch height control in more depth in another video, but what's going to happen here is when the machine's going to read through this code, look at this line right here, preset volts is set to 78. Okay, so it's going to change that voltage for us. And that 78 volts is very important. It's because we are using a 45 amp fine cut tip. Okay? If I was using a standard 45 amp tip, it would be closer to the 120 volts. Okay? More like in that range. But because we're using a fine cut tip, it runs at a much lower voltage. So it's very important. We'll talk about it more when we discuss the torch height control in depth. But as you can see, I hit run, the machine ran through that first part of that code, and it set up my voltage for me. So it's very important. And now it's asking me to resume. If I hit resume, the machine will start the motion and start the cut. Okay, so I'm going to hit resume. Let me turn on the camera here so you can see what the machine does. And the machine's going to move up and back to the first cut and start to move through the operation without cutting. And this is a chance for you to see how it's reading through the code as it goes down. It's going to start the perimeter cut. Now I'm going to hit pause. When you hit pause, you always want to hit pause in between cuts. Okay? You don't want to pause it while it's cutting. Okay? So it's very important. You always pause the table in between cuts. If you do that, you can simply hit the resume button and it will start back up. Okay? And continue the cut. Pause. Resume. Pause. Resume. So, I paused it during the cut. Now, what I want to point out here is that the torch on button is lit up. So Command CNC is firing the torch right now. Okay, if we didn't have this, if I uncheck this, the torch will fire. Okay, so the machine would be attempting to fire while it's just sitting there. What's going to happen is your machine's going to burn away too much material and it will lose arc and it will turn off the plasma. You will not be able to just hit resume and have it run, okay? Because the arc will not automatically refire and restart the cut, okay? So it's very important that you do not pause the table during a cut. Now, I can rewind it and fix the issue, and we'll discuss that in later videos on how to take care of that. But for now, just practice doing your pause and not doing it during a cut, okay? So the machine ended, and it moves back to the zero position, or part position, zero position, okay? Okay, so a few more things about the G-code. This button here is to rewind the G-code, or essentially refresh it from the beginning. That's very important. It makes sure that the machine is read through the code properly. You have a go-to line here. You can tell it to go to a specific line. Okay. Say you want it to go to 150. It went to line 150. Okay. That can be very helpful if you have a large nested code and you stopped in one particular spot. You do have the ability to, if you're careful and you set your cuts up correctly, if you go halfway through a nest and you have to shut the machine down because you're leaving for the weekend, you can come back and pick right back up where you are if you follow the correct sequence. And so, you know, writing down the line of code you're on and whatnot, this is all part of it. If you hit, this closes the code and this edits the code. This pulls it up and I can make changes to this code. Okay. I do not recommend you do this necessarily unless you know exactly what you are changing. If you properly set up your cuts in SheetCam, that's the best way to make changes. You know, because some people will say, well, I want to change my speed. Well, your speed is set throughout the code, and you would have to go through each individual spot and change the feed. You know, feed 250, feed 250. These would all have to be changed. You can't just go change one spot necessarily. Okay. So if you close this, the machine reloads the code to see if you made any changes. Okay. And so that basically covers doing a dry run, reviewing the part display window and the G-code display window. Next video will be doing our first cut with the torch drive control off. Thank you for watching.